Now for number 42, we certainly are using Dalton's law of partial pressures, but we're also going to use another gas law, and I'm going to see if we can use our logic skills to figure out what the other gas law we should use is. So let's use Dalton's law first. So a sample of oxygen is collected in a 175 milliliter container over water at 15 degrees Celsius. So we're going to have to find out what the water pressure is at 15 degrees Celsius. So 15 degrees Celsius is 12.8 torr. 12.8 torr. And the barometer, right, which reads atmospheric pressure, is 752 torr. And so we're trying to solve for the partial pressure of, they call it oxygen, so I'll call it oxygen too. Partial pressure of oxygen ends up being the 752.0 torr minus the 12.8 torr. And that comes out to be, where's my calculator? 752 minus 12.8, come up with 739.2. 739.2 torr. So this is the pressure of that oxygen gas, but this is not my answer. This is not my answer. I'm being asked, what volume would that dry gas occupy at this pressure? Same temperature, but this different. So I have a different pressure. I have an initial pressure. Okay, that's this initial pressure right here. I have a second pressure. So I have a P1 and a P2. I have, what else do I have? I'm being asked what volume, so this would be a V2. Do I have a V1 here? Yes, I have a V1 right here. But if you're kind of curious, what about this 15 degrees Celsius? I have temperatures. But do they change, right? Do you see that they do not change? In other words, temperature remains constant. Which gas law has temperature remaining constant and uses two values for pressure, two values for volume? That's Boyle's law. So we're going to rearrange Boyle's law to solve for V2. And we can plug in the values that we just generated. Now we had to generate this value for P1, 739.2 torr. So the question gave us the 175 mils. And the question also gave us the 770 torr. Now I'm dividing torr by torr, so those cancel. Milliliters is my only unit left, and that's what I'm trying to solve for, so that actually makes sense. So come here, calculator. The 739.2 times 175, then divided by 770. I come up with 168, and yes, I do want three significant figures, and because I'm now multiplying and dividing, and that's three sig figs right there. Final answer, 168 milliliters.